Okay, example 1. Suppose that after you are loaded into a Ferris wheel car, the wheel begins turning at 4 RPMs. The wheel has a diameter of 12 meters and the bottom seat of the wheel is 1 meter above the ground. Express the height h of the seat above the ground as a function of time t seconds after it begins turning. So the first thing we need to do before we start the problem is come up with a little picture. So here's a picture of my Ferris wheel. It has a diameter of 12 meters. It is 1 meter off the ground. Okay, so if I'm at the very top of the Ferris wheel, this would be my max. How high am I off the ground? Well, if this is 12 and I'm 1 meter off the ground, my max is equal to 13. So my maximum height of the Ferris wheel is 13 meters. My minimum height on the Ferris wheel, if I'm at the very bottom seat, I'm 1 meter from the bottom of the ground. So I have my max and I have my min. In order to graph this, I'm going to need the axis of wave, the amplitude, the frequency, and the period. The amplitude and the axis of wave are simply a formula. Amplitude says you take the max minus the min and divide it by 2. So if I take 13 minus 1 and divide it by 2, I get 12 divided by 2, which is 6. So my amplitude is 6. To get the axis of wave, the formula says you take the max plus the min and divide it by 2. So 13 plus 1 divided by 2 is 14 over 2, which is 7. So my axis of wave is 7. In order to finish graphing, I need to get the period and the frequency. So the period is how long it's going to take me to go around the Ferris wheel one whole time. In the problem, it tells me the wheel begins turning at a rate of 4 RPMs. That means it goes around 4 times in 1 minute. Well, I just want to know how many times it takes to go around one time. So if I think about it, if they want this problem in seconds, there are 60 seconds in a minute, and it can go around 4 times in 60 seconds. So 60 divided by 4 gives me 15. So my period is 15 seconds. It takes 15 seconds to go from the bottom of the Ferris wheel all the way back to the bottom. In order to get the frequency, I'm going to use my formula that says V equals 2 pi divided by the period. So I'm going to have 2 pi divided by 15, which is just 2 pi over 15. The last thing I need to do is sketch a graph. Once I sketch a graph, I should be able to write the equation. So when we were graphing yesterday in class, I said make your x-axis go out to the period. So it's going to go out to 15. And then I always tell you to half it, half it, half it. After we did that, I said, okay, always go do your axis of wave. My axis of wave is at 7. So I go to 7 and I draw a dashed line going all the way across. I know my max is going to be 13. My minimum is going to be 1, which should make sense because my amplitude is 6. So if I go up 6 from 7, I'm at 13. And if I go down 6 from 7, I'm at 1. The hardest part of these types of problems is to figure out how to start the graph. I have to decide, should I start at 13, should I start at 7, or should I start at 1? So you have to think about what the problem is about. You're on a Ferris wheel. Do I get on the Ferris wheel at 13 meters at the very top? Do I get on the Ferris wheel in the middle at 7 meters? Or do I get on the Ferris wheel at the bottom at 1 meter? Well, anytime you've ever been to a theme park or anywhere they have a Ferris wheel, you always get on at the bottom. The bottom is never on the ground. This one is actually at 1 meter. So that's where my graph is going to start. As I go around the Ferris wheel, my height is increasing. So I'm going up, up. After I get to the top, I come back down to where I started. So I go down and down. Now I can sketch a picture. So with the picture, I can decide, is this sine or is it cosine? Well, it didn't start on the axis of wave, which means it's going to be a cosine curve. It started at the bottom, so it means it's going to be a negative cosine curve. So when I write my equation, they want me to write it in terms of h. So the height is equal to, I always write my amplitude next, and because it's opening down, it's -6. We said it was going to be cosine. My frequency is 2 pi over 15, and my axis of wave is 7. That is my equation for the Ferris wheel problem. -6 cosine, 2 pi over 15 plus 7. This is my amplitude, this is my frequency, this is my K, my axis of wave.